Hello all. Welcome to the fourth part of this short series of Quality Assurance Engineering. This is George Pligoropoulos. This is my LinkedIn to know a bit more about me. And today's video is going to be about QA strategy and regarding human resources. And this is basically the very common question. Like I have 10 engineers, 10 software engineers. How many QA should I have in comparison? And today I don't want to give you the rule of thumb. The rule of thumb, it could be very much dependent on the company. It could be 1 to 1, 1 to 3, 1 to 6. It really depends, on your resources. But I want you to go through a journey together to see how you might answer this yourself for your own team and your own resources and what you want to achieve. And so basically, you start with that. This is the ideal scenario. Uh, if you have the resources, by all means, then please, there's not much I can say more in this video. You have here the database, the backend. You have multiple components. You might have multiple front ends, multiple microservices. If each of those has its own QA team that have both manual and automation skill, then there's nothing more you can do, right? You might be also near to one ratio, one engineer, one QA, which has, I mean, this is the ideal if you have many resources. The unfortunate thing is that not very companies have those resources or are willing to spend or invest on QA. So usually the situation is like so. So this is the reality, how it looks more often than not, that you have a few QA engineers, and if you had no QA department at all, and then you have a QA department with an official title inside the company, then everyone will, and rightfully so, since bugs are commonplace. You're always going to have bugs. Everyone wants this reassurance. They like this reassurance. So if there are many teams, there are going to be many requests for help. So there might be a single QA engineer or a few QA engineers being pulled in all directions from all teams. The more good they do their job, the better they do their job. Actually, the more requests from various teams, and this is something that needs to be managed, right? Needs to think of okay, you have a QA team, and there is a reassurance that it's going to cover a lot of scenarios, but how will the engineers should respond to having a QA team present? And another way to rephrase this is where to cross the line actually between the QA and the engineering team, and how to integrate them optimally. Again, in order to optimize your human resources uh, for the QA team. And let's go through an example, right? This is the best way to do it. And let me put this here at the top. Um, so let's go through these 8 scenarios. Bear with me for a moment. So you have the registration form here. Imagine a very simple registration form, and when submitting this with valid values, then it should create a new user. Second scenario is leaving the email empty should not be allowed, of course. Third scenario is that the verification email should arrive, at the same email address that the user specified. Fourth scenario is clicking actually the verification link should make the user, should allow him to log in if he couldn't previously, and be treated as a verified user in general, and verify that clicking the verification link a second or more times, given that it was successful the first, will yield a warning. And so this was the fifth. The sixth scenario is that, if you are a hasty user, you click the submit button a lot of times, and then at the end result should be treated as a purchase button. So it should yield a single registration. And again, two scenarios that if you attempt to re-register with the same email, then the user who is not verified should be allowed to re-register. Maybe this is debatable, but let's consider in our case that this is how the requirements are, and that attempting to re-register with the same exact email, a user who is already verified should not be allowed. This user can log in and manage his account, for example. So you have these 8 scenarios here, and don't take them like literally that you have scenarios written by the QA. Imagine that these are actually things that your customer would expect from you, the company that is delivering the software product, to have tested already, right, before the delivery. The customer doesn't care that you have engineering teams, you have QA teams, etc. Really, it's not his or her concern, and and the point from you is now where to cross the line. I mean, what did you expect from the engineers regarding those scenarios? What did you expect from the QAs regarding those scenarios? One thing that is expected from, for example, from the QAs is to actually write those scenarios, write them down, do the test or QA analysis, as we say this, which is very similar and near the business analysis, or it's like it comes right after, before any coding, ideally. And okay, and you have the scenarios. And this is, you could say, the faster part of the whole process of ensuring the quality. The slower part would be actually executing those scenarios. No matter how you proceed with that, I mean, if you want to write automation scenarios, it will take you sometimes to write the automation scenarios. If you do it, if you execute them manually, writing the automation scenarios means that the execution is very fast afterwards. And executing the scenarios manually, it takes some time, right? And the point is how you're going to treat that. And let's go to the next slide. And let's consider that there's no QA team at all, right? This is how it used to happen in your company. Like maybe you're in a company for many years, or you remember how software companies used to be, that there was no QA team. So basically, all dev executions, or not at all, as I say there, you can see in the red letters, the vertical ones. And so basically, the line is at the bottom, meaning that everything above is for developers to execute them. I mean, someone needs to do it. Might be someone else who is not his responsibility. So the business analyst might help. The product owner himself might help. But having the product owner, having crashes or bugs in these very, all of these scenarios are very simple things. Like, the product owner needs to have at his hand or at his computer, his screen, the final product, so he can give a more valuable feedback, business wise, in case we need to change anything, not fall on bugs. This should be covered before the product, the new feature reaches the product owner. And of course, the bugs never reach the customer. And so have no QA team at all. all dev executions. This is how it used to happen. And someone could say you could consider the opposite, that that all of these scenarios, it was written by the QA, it should be executed by the QA. But imagine how slow this makes things. How many QAs you would need, even if you're hiring juniors, right? Just to do the executions, how many you would need? Like you need to do uh, like a lot of executions, and this is only a small example. You could have many more scenarios, and um and yeah, I mean. This gives no incentive to the developer team to actually read the scenarios and catch any bugs, prevent bugs before they are actually deployed ever. Um, but this for sure you're not doing optimal human resources of the QA team, because you have kind of separated that someone is developing. We don't care what they develop, because always we're gonna have the QA to do the executions. I mean, how could this ever be optimal, right? Um, and let's go to the third one. We're not explaining here why is this optimal, but the claim here is that at the top here, for convenience and for this presentation, I have made it a little bit simpler. So you have four scenarios at above the red line and four scenarios below, and basically you have all the very very happy path basic scenarios uh, to be in general in the responsibility of the dev team, let's say, like before announcing any delivery. Now, why is that? This is because of the systematic issues that you can have in a in any complex software product, right? Because of the libraries that you're based on all of this perhaps legacy code that you could have inside your system. In general, a lot of people writing code. You have the issue here. You have like that you might have a very very good engineer who has done what exactly? Has written the proper code, there may be a very clean, a very robust code for this particular task for the registration, but he might not have considered other aspects of the product which interfere with the registration. And therefore, I mean, any example here, like you could have like a library that has analytics, or that is only in the background, or you might have some marketing pop-ups, or anything you can imagine. And basically you have very very simple scenarios here, and if you give all the responsibility of the executions to the QA team, you might have crashes for these scenarios, not because you have bad QA engineers, not because you have bad software engineers, or it's just because nobody they announce a delivery without anyone ever like launching the web page to see how it looks, just to do the happy path. um, and this is very 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 important, right? Because if you think about it, this happens in the software world, but you wouldn't expect this as a customer from nobody else. um, from nobody else. I mean, you go Um, yeah, I mean, anything like you have again, someone, for example, a technician, a car technician saying to you that I did everything that a Ford company asked me to do, all the steps, but I didn't take the car to have a drive around the block, right? I never did it, and it was delivered to you, right? um, and this is imagine the more serious scenarios like changing your tires and never having, uh, you know, uh, just test a little bit before actually delivering to the client. And this is something that can cause huge friction actually, and headaches and all of that. And let's start. Let's go a little bit beyond here, and let me check something about the time. Sorry for that. Uh, okay, go back to the slideshow. So, so basically, what you have here, you have the dev team and the QA team. You have, for example, too many major defects. All handled, happy customer. Major defects. The QA team is always there, and this ping pong that you see here in this animation happens between the two teams. The customer is happy or very happy, depending. Because the delivery and project manager has asked the QA team, you're gonna catch all major defects and we're gonna handle all of them. Sure, you have a happy customer, but more and more furious project manager because actually the team velocity is decreasing. So you see here, and this is the sprint number as we go. This is the axis of time as we go from one sprint to the next. The project manager becomes here furious and furious, more angry, and the customer, as we said, is happy. And this is what we were just describing, right, in the previous slide, that if you have all these small things, and this can happen also from project management, right? If you have the developers being under pressure more than they can handle, then they're going to do hackery solutions, hackery stuff, and they're going to deliver things that actually seem that they work. They might also pass the code review, but it crashes or has various defects on the QA side because it was under pressure. It was not properly thought out, and you can have that. And and this is a situation that you can have the customer happy, but the customer eventually, maybe we should go to sprint 40 here. After many, many time, what will happen is that because of the delivery of the velocity is very low, you have the customer being like abandoning the product altogether because there's another competitor now that can deliver fast and at the same time keep the quality high enough so the customer is happy with the innovation of this other competitor, and you're out of the game, unfortunately. um, and you can have the opposite situation. So you just do not care about major defects as a team. You have a happy project manager, so the project manager is always delivering, right? But something you might not know if you don't have analytics, if you don't measure your bounce rate, if you don't measure your retention, and the customer here gets more and more frustrated because the quality is decreasing and might be also silent how this happens. And yet here you might be losing huge opportunities because the, this is the developer team there in this GIF, this animation, and you see the guy leaving the ball drop. He doesn't care of solving the defect at all, and this is the opposite situation, and you don't want to have this either, right? And going through the here this slide, uh, this is the final slide of this video, is that we need to remind ourselves of this law of nature of the fast, good, and cheap. And these circles here do not overlap in the middle, because whoever tries to reach this, maybe it's very, very, very difficult to reach this. And you know, if you ask me, I guess the best way to be is around somewhere around here in this overlap. And we have here the project manager who cares for quality, the QA cares mostly, cares for speed, the QA cares mostly for quality, and the product or stakeholders care for fast and good as long as it doesn't break the bank. And actually, um, this is how you manage. This is what you have in mind when when you're thinking about your QA human resources. Because imagine without QA, you're somewhere here, right? You might be here, you might be a little bit faster and a little bit more expensive. You might be here, for example, but you might be somewhere here. Now the QA is trying to push the whole situation towards the good, right? The QA comes to remind of the added value of the quality and how to keep the customer on the long term of the long investments. Is something Quality is something that it's difficult to be measured, but using gut feeling and some analytics, you can measure it. Um, and uh, and the point is that, the more, first of all, the more QAs you're bringing means you shouldn't bring them, without thinking that you're moving a little bit away from this space here, right? And I doubt that someone would be here. I mean, if you want to leave a comment in this video, you can for sure. I doubt that someone is here, because usually, as we said in the first video, it's about timing. So people want to be fast in their delivery, and the point is that as you're bringing QAs, you need to think systematically how you're going to increase your quality, because QA is going to pull you to here. But if you don't have the resources to support this, so for example, if you have very few engineers, you might not even have uh, capacity. You might be very early at your development, for example, and you want to do some internal testing without having a separate QA team. Even though a single QA person it seems necessary, even for the very early startups. And the point is that the more people you're having. So if you go back here to this ideal, you see that here you have hired a lot of QA people. That means that you are very near here, and you have all the processes and established the processes. You have optimized the processes, and you have found your ideal ratio. And so you have to think about that when you're trying to you have to think about all of those things that we discussed today, and about where to cross the line here. Um, Depends on many things, on your complexity of your project, on what kind of engineers you have brought in the team. A lot of things play a role. If the culture is good enough for the engineers to deeply care, or not perhaps care so much, that it might be something else that you need to tackle. Um, and I hope with today's video it helped you to start thinking about, how to find this ratio, between how many QAs versus developers you need on your own. Thank you very much. This was again QA Strategy Human Resources by George Pligoropoulos, and thank you very much for your time, and see you on the next video.